Thank you for watching this video. Chapter 9, Access Control List, Part 2. It's Semester 2, Routing and Switching, by me, Astrid Krasniqi. Okay, we finished part 1 of this chapter, so you should be watching that. Now we're going to continue with configuring extended access control list. The procedural steps for configuring extended access control list are the same as for standard access control list. The extended access control list is first configured, and then we activate it to the interface. Command syntax and parameters are more complex to support additional features provided by extended access control list. So here we are permitting, for example, access control list 103, permit the protocol, the source, destination, and the port number. So that's what extended access control list allows you to configure based on the protocol, source and destination IP address, and the source and destination port numbers. On here we are permitting port 80 and port 443, and then coming back established TCP connection. Okay, so we're gonna do here on the demonstration, same demonstration as we had on the standard access control list. I just have deleted all the whatever we had, Shovan, all the access lists that we had before. So there's absolutely no access list now. So what we're gonna do here on this exercise, we're gonna configure extended ACL to we want to deny PC2 to go to the server if they use ICMP, if they ping the server, but allow PC2 to go to the server if they use web. Then we want to allow, let me copy all this, paste here. We want to allow PC1 if they go to the server, but we want to deny PC1 if they use the server's www. Okay, so this is what we want. PC2 can't ping but can HTTP. PC1 can ping but can't HTTP. These are the requirements. So if I start the router 1, so if I go inside there, start configuration, right, config T, access list, then I'll choose extended, so say 105 this time. Access list 105, permit what protocol? We are permitting ICMP and source. So the source address is going to be the host PC2. So host of PC2 is 10.1.1.200. And where is it going to go? The destination. So the destination is going to be host our server 192.168.1.254. That's it. Then same access list 105. No, I got it wrong, that one. So no access list 105. Right, let's start again. Access list 115 this time. We want to deny PC2. Deny ICMP host 10.1.200 to host 192.168.1.254. We want to allow PC1, so access list 115 permit ICMP host PC1 to host 192.168.1.254. Okay, that's done. We allowing PC1 to ping, we denying PC2 to ping. Now we want to allow PC2 to web access, so access list 115 permit TCP, now coming from host 10.1.1.200, that's PC2, going to 192.168.1.254 equal with 80. Let me just expand this a little bit so we can see all. Okay, so we are permitting TCP communication from this host going to this host as long as they're using port 80. Now we're going to deny access list 115 deny TCP host 10.1.1.100 going to the host 192.168.1.254 equal web access. Okay, so we're permitting host 2, but we denying host 1 or PC1. Then I'm going to say access list 115 permit any to any, or access list 115 permit IP any to any. Okay, now do show run. Right, these access lists are here, but they are not in the effect at all. So we have to bind them somewhere, or we have to add them somewhere. So we're gonna put them as close to the source as possible, since it's extended access control list. So I'm gonna go to the router on the interface FA00 is the closest. So interface FA00 IP access group 115 in. Do show run. IP access group 115 in, and access list 115 says deny PC2 ICMP for the server, allow PC1 to the server, allow TCP communication from PC2 to the server as long as it's web, and deny PC1 to the server as long as it's web. Everything else is allowed. Okay, excellent. So we're going to go to say PC1 first. Try if I can ping the server. So ping 192.168.1.254. Okay, this should be allowed. Yeah, we have a reply from the server, so which is good. Now, if I go to PC, let me move this here, and if I can bring PC2, have them in the same window. That's PC1, and that's PC2. So if I can bring PC2 here, go to desktop, and I'll ping the server 192.168.1.254. Right away for the saying, got a reply from the gateway. They're saying destination host unreachable, so it's denying me. Right, can access the web on that server. So 192.168.1.254. Yep, I can access the web site. What about this site? 192.168.1.254. So PC1, the web access is denied. Request timeout. But PC2, the web access is allowed. But ping is not allowed here, but is allowed here. So our target has been achieved right away. So PC2 can go to the web access but cannot ping. PC1 can ping but can't go to the web access. Now, complex access control list. Now here we have a, let me just start the slides from here. Dynamic ACLs. Users who want to traverse the router are blocked until they telnet to connect to the router and are authenticated. Until they telnet to the router and authenticated, they can't traverse. Reflexive ACLs. They allows outbound traffic, but limits the inbound traffic only if it's been initiated from the inside. Time-based control the time. From the time they can allow the access list from certain time to the certain time. Now, reflexive ACLs I want to talk about is everything else will be blocked. It will be like a firewall here. Everything will be blocked until the traffic is initiated from inside. If the traffic is initiated from inside, the router will create like a hole, like a punch hole on the firewall, and it will allow the returning traffic. If traffic is initiated from outside, then the router will just simply block it. Okay, that's what we're gonna do now. So we're gonna create like traffic from outside. So let's bring one network here. So this is my network. So on that network, I'm gonna call it internet, and in that network there's gonna be a PC, a server, and a router, and a switch. Okay, so I'm gonna connect this together. So IP00 with the switch, doesn't matter where. Switch with PC1, and switch with the server. Now the network here is gonna be say 192.168.200.0/24. Okay, this server, the address is gonna be 200 as well, and this PC's the address, the IP address is gonna be 100. Well, no, 1000. 192.168.100, 200, 100, 192.168.200, 200, and the router's IP address is going to be 201. The IP address. Now, let me just save this and write. Okay, I'm going to switch it because I'm going to switch it off. So switch it off. Populate it with WIC2T. Sorry. Switch it on. Bring the router, the router, switch it off. WIC2T, populated, switch it on. Connect those two together. Alright, I will pause the video, do all of the configuration necessary, and resume when everything is, everybody can. Okay, all configuration is done, so I went to this PC0 here, and tried to ping it. I pinged the PC1, so it worked fine. I'm gonna try and ping PC2. Yep, that works fine as well. So go to PC1 and try and ping those two addresses. So I'm gonna ping 192.168.200.100. Yep, I got reply, and 200. Yeah, I got reply there as well. Okay, so here what I use, the network 172.16.12.04/24, and then that did the default route both ways. Okay, so now the computer from the internet can ping our local network here. So it's initiating the traffic there, and I'm pinging the PC on inside the network. It's going all the way there. Now what we want is, if the traffic is initiated here, should not go inside. It should be dropped here. If the traffic is initiated here, then it's fine. It can go outside. So what we want to do is, if I open the, say, paint, it'll be easy. Right. So we're going to create a new access list. So access list, say 151, say 131. Permit. What do we want to permit? Our network. So it's going to be permit IP any to any. Okay. Now we say access list 131 permit IP any to any, and then we say access list, say maybe 132. We want to permit TCP coming from anywhere, and if they go into our network 10.1.1.0 with a wildcard mask 0.0.0.255 and they have a TCP established, and access list 132 permit ICMP coming from anywhere going to our network with a wildcard mask of all zeros and 255, and if it's echo, reply. That's permitted as well. Then we can apply this on the interface. So interface all zeros IP access group 131 out. So that's going to permit anything from our network going to anywhere, and it's going out. And you say IP, same interface, IP access group 132 in. So they can come in as long as it's established, and it replies as well. Okay, so I'm going to copy that, go to the my router, and exit, paste it here. So access list 131, permit IP any, and 132, permitting established, and record reply. Do short run. Okay, that's from the before that access list. Okay, so we have 132, 131. These are the statements that we are interested. Okay, so if the traffic starts from here, it should be fine to go there and come back. So go to PC1, and I'm going to try and ping that PC there. So go to desktop, ping 192.168.200.100. Okay. Yep, I have a reply from that PC. So everything is working fine. If I go to that PC and try and ping the PC1, returning traffic. So ping 10.1.1.100. Now it says destination unreachable. So this PC can ping this PC, but this PC cannot ping this PC because the traffic is being initiated here. So if it's initiated here, it's going all the way to the router here, and this router is blocking it. But this traffic is going, and then this router is allowing to come back. So if this PC2 can try and ping or access the web on this server. So if I go to the server, on URL type 192.168.200.200. Yep, I can access the internet on that server on the internet. Can I ping that server on the internet? So ping 192.168.200.200. Yep, no problem whatsoever. The reason why I can do it is because the traffic is being initiated here. If it's initiated on the server, they should work. It should not work. So ping 10.1.1.200. No, destination unreachable. So this is reflexive access control list, where the traffic is allowed to be initiated inbound. Now, type of IPv6 access control list. So access control list named, we have for version 6 we have named only. Everything is similar to functional to IPv4 extended access control. Although IPv4 and IPv6 access control lists are very similar, there are three significant differences between them. So first of all is applying the access control list. We use IPv6 traffic filter when you want to apply the access control list. And we don't have any wildcard mask, so we use the prefix length is used to indicate how much of the IPv6 source and destination address should be matched. To configure the IP access list, the three basic steps. First, you configure the IPv6 access list name. Then you put permit or deny statements, and then you bind them. So IP access list, IPv6 access list, no FTP, deny TCP, deny another statements, then permit statement, again implicit deny is there as well, and then you bind them to the interface, or you link it to the interface. IPv6 traffic filter, no FTP to 11 in. Okay, so on the summary, an access list is a series of permit and deny statements that are used to filter traffic. Standard access control list identified by numbers 1 to 99 or 1300 to 1999. Filter traffic based on the source. Remember, only the source address. Extended access control list, identified by 100 to 199 or 2000 to 2699. Filter traffic based on source IP address, destination IP address, protocol, and port numbers. Named access control list is above 11.2, iOS 11.2 and above. Can be used for either standard or extended. Access control list uses wildcard masks. 0, check the bit. 1, ignore the bit. Complex ACLs, we talked about dynamic, reflexive, and time-based. Implementing ACLs, first create the ACLs, second place the ACLs on the interface. Standard ACLs are placed nearest to the destination. Extended access control lists are placed nearest to the source. Use the following commands for verifying and troubleshooting access control lists. Show access list, show interfaces, and show run. Thank you very much for watching. This has been Astrid Krasniqi helping you with access control list.